What's the tallest a building can be? Have you ever wondered? How many floors would it have? That's the million-dollar question, but let's find out. There are many problems to solve when building higher than the Burj Khalifa, the current tallest building in the world, with its 828 meters in height, located in Dubai. Theoretically, and according to some experts on the subject, a building can be as tall as 8,849 meters, just 1 meter taller than Mount Everest. It would have around 2,949 floors. Based on these calculations, the base of this colossus would be about 4,100 square kilometers. To give you an idea, 820,000 soccer fields would fit in that area. The building would take up a large area, even with a hollow core. How did they determine these numbers, and what if you build higher? Well, building higher and higher basically means solving a series of problems that come along with the idea. These issues prevent us from building structures 2 or 3 times taller than the Burj Khalifa. There are basically 5 main problems: materials, human limitations, elevator technology, building sway, and money. Building a structure that tall would need materials and construction methods that don't currently exist. Lightweight yet very strong materials are needed to support the structure's weight and endure wind and other environmental forces. In addition, these materials must be resistant to sudden changes in temperature, humidity, corrosion, and other factors. Materials like carbon nanotubes, graphene, and advanced compounds could offer needed strength without much added weight. These materials must also be extremely resistant to compression and tension, because a building of this magnitude exerts a colossal vertical load on its base and also endures extreme lateral forces from the wind. For example, the World Trade Center's Twin Towers, with just 110 floors, weighed around 250,000 tons. While the Burj Khalifa weighs about 500,000, an enormous weight which requires a very well-built foundation to be able to support it. And why not use cement? Well, cement is a good construction material, but it has limitations regarding compressive and tensile strength, specific weight, among others. Also, its density would make the foundation so heavy that the ground might not support it. Also, a foundation made from it couldn't support the heavy weight above and would fail. Additionally, you must find a way to transport the cement up to 8,849 meters and ensure it doesn't dry out before arriving. In addition to keeping workers alive at such high thin air altitudes. And besides, of course, finding a very solid rock where the building can be constructed so that the ground doesn't give way under the colossal weight of the structure. When it comes to human limitations, the Burj Khalifa, with its 828 meters, already causes some people to experience discomfort because of the altitude. However, in a building that's 8,849 meters tall, which is about 29,000 feet, the same altitude at which airplanes cross the skies, no one could survive. Since at such extreme altitudes, the atmospheric pressure is significantly lower and consequently, there's less oxygen present. That being said, such a building would need to have life support systems and internal pressurization. In other words, the same thing that's done to keep passengers alive inside airplanes, by pressurizing the cabin so that the air becomes breathable. Besides that, the temperature at those altitudes can be as low as -71 degrees Celsius, which is already a problem for any kind of life to exist under those conditions, with strong winds and other weather factors. This means that in an event where one of the main windows breaks, the building would immediately lose pressurization, which would already cause deaths. Also, air at -71 degrees Celsius would enter, causing damage. As for elevator technology, that's definitely the most important part, for there to be habitation in the building. Skyscrapers require proper elevator systems, and currently, elevators have limitations in terms of height and speed of movement due to various technical and safety factors. The fastest elevator in the world right now is in the Shanghai Tower. In China, it can reach 74 kilometers per hour or 20.5 meters per second. It can go up 118 floors in 55 seconds, which seems pretty fast, and it really is. However, assuming that the hypothetical building is 8,849 meters tall and has about 2,949 floors, it would take this same elevator 22 minutes and 58 seconds to reach the top floor. Hypothetically speaking, that's too long to be in an elevator. In such tall buildings, elevators must be extremely fast to keep travel times acceptable. However, this introduces significant challenges related to safety, stability, and occupant comfort during acceleration and deceleration. In extreme emergencies on upper floors, elevators are the only quick and safe way to evacuate. In other words, beyond making elevators faster, they must also be safer and more viable for use in extreme emergencies, like earthquakes, building explosions, fires, and airplane crashes. You remember September 11th, right? Additionally, the traffic control issue must be addressed to reduce wait times and improve the movement of people and cargo within the building's elevators. There's also the problem of the building swaying due to its height. For a building that's 8,849 meters tall, controlling swaying and vibrations is crucial because of the building's height and ongoing risk of collapse from wind and other forces. I've already made a video about techniques and tricks skyscrapers use to reduce wind oscillations, ranging from tuned mass dampers to the building's very design. Using a large mass damper at the top, as in Taipei 101 in Taiwan, isn't feasible here, given the height of the building. Several will be needed on multiple floors, or new oscillation dissipation technologies must be developed. The building's own design is also very important and should be done in such a way as to minimize as much as possible the occurrence of oscillations caused by the wind, just like it is done in the Burj Khalifa. Remember that the tuned mass damper of Taipei 101, which has only 101 floors, already weighs 660 tons. Imagine the size and weight of the damper for a building with 2,949 floors. I won't discuss the costs of building a structure this large because they're truly incalculable. Building a structure 8,849 meters tall would be extremely challenging, complex, and impractical. With current technology and materials, even widely used concrete couldn't serve this purpose. In fact, there is no real need for such a structure.